Okay, what we're going to do now is we have questions up here that we haven't addressed yet, and we pulled these out because they're big questions. Okay, they're going to require input from more than one panelist, we think, and there's about 40 of them up here. I'm not quite sure how this is going to go, but we're going to try to do it. Okay? The first one's for me. All right? Just came up. Oh, okay. It said, mentioning the need to be able to adjust. Do you think the mandatory incorporation rules need to be adjusted, considering the national push for soil health? I love short answers, and the answer is yes. I mean, a site-specific determination of whether incorporation should happen or not happen on a specific piece of land is the way things should go. That determination should be made, taking all the factors into play. In some places, it's going to be a positive thing to do. In other places, it's not. So yes, that flexibility needs to be available. Done. Okay. Next. All right. This one I like because it's really written very nicely. So that's why we're starting here. All right. This is for the entire panel. So everyone pay attention. Even you, Clement. Okay. All right. In the 1990s, when Pfisteria hit, many of us learned for the first time about soluble P moving out of soils independent of erosion. Bombshell, it says. Next, we hear that soluble P leaches through soils or moves via macropores. Another bombshell. Now we hear about conservation tillage and the top 2 inches of P and P loss from the top 2 inches. Another bombshell. It says bombshell in here. And today we learn about dissolved P from loss from cover crops. So can you tell us, about any other concepts or conventional wisdoms that are, I can't read that word, that are, that we need to think about when addressing P loss that may be misconceptions and may be wrong? Bombshell. Anybody?
I think that covers Andrew's career, 1976 to 1984. So,
I think all of us would probably say, to a certain extent, those are true. But it's like Frank ended up saying, it's baby steps. And although some people have, maybe they are bombshells, as no-till and cover crops do leak some phosphorus, but if you look at the big picture, they've reduced the loss of phosphorus much, much more than what we're talking about this little bit. This little bit tends to be, obviously, in some cases, sufficient to cause algal growth, but, and it's more available, but the bottom line is they have been a huge benefit. So I don't think we want to go away. I know Frank, we were discussing it earlier with the message that these are bad. They're not. They are improve soil health, improve the environment because they've reduced 90% basically nutrient runoff and phosphorus runoff. But there's a few trade-offs, and I don't think they're bombshells, and we shouldn't take that out of the proportion or out of context of the benefits that they have put in, because I don't think we want, any one of us would want to see them be discouraged from doing because of hearing about that trade-off.
All right. Anybody want to add to that? No?
Yeah.
Okay. Walter, go ahead.
This is sort of like a little bit of a good news bombshell.
Hold that really close to your mouth.
And I think folks studying the ecology or the water quality aspects of the bay, we used to think that the bay has been nutrient rich since John Smith was sailing around. Therefore, it'll take about that length of time to get it right again. I think monitoring data, laboratory experiments, and more sophisticated modeling all lead us to believe that should substantial load reductions occur, the bay will respond in terms of water and habitat quality much faster than we had anticipated. So to me, what I've just said took me about half a decade to get my head wrapped around and believe. But I think the water quality community is coming around to that point of view. So to an extent, that is a very good news bombshell.
Just one other, is that all right? Would be that in our eastern Arkansas, we're now seeing poultry production. There's a new integrator opening up, which means 600 or 700 new houses, which is a lot. And the farmers think that's great because they're going to get poultry litter, and they are row crop, they are zero tillage, they're leveling the lands, and you put poultry litter on, you're going to get a yield 2 or 3 years ahead of time. So there could be great benefits, but it gives us an opportunity to not have those bombshells, because if we work together, we can develop nutrient planning that encompasses a sustainable system. That's one thing that we can learn from what we already know and help to get that system in place as it's been developed. The other thing that I know some people in the audience have seen, that you see some confined feeding animal operations moving towards the biofuel industry in the Midwest. And so we are starting to look at creating some of these imbalances. It's not in the Bay anymore. It might be in the Midwest, where you've got biofuel production that generates distiller's grain, which is a wonderful supplement feed for animals. And they like it. And I've talked to veterinarians who told you that cows will actually select that out and eat it preferentially, but it's a gooey mess. So they eat basically all the feed they give them. But it's very high in P. You've got to manage that DDGs, dry distiller's grain, carefully. Otherwise, you're going to increase so we know these things are happening. I think we've got the science. That's another, I won't say it's a bombshell, but we are seeing these centers that maybe it's not in Delmarva, but I think there has been some movement of, animals to go next to those biofuels, because then you've got that cheap feed. It only has to go a few miles to the feedlot. And, those are some of the things I think we could be managing. And I don't think that's a bombshell, but I think we've got an opportunity.
All right, thank you.
I'm just going to add the last one. This isn't about a bombshell as much as it just kind of shows how long it takes for the science to trickle out to folks that are going to act upon it. And so I think a lot of what we talked about today, we keep joking that Andrew, had done these studies in the early 70s and 80s, but it was only half in jest. He did came to a lot of the conclusions that we're reaching today. And so there is got to be a better way to get our information out. It's a little frustrating, I'm sure, if it takes 20, 30 years for you to be heard.
Okay, we're going to switch gears a little bit. Tony, start paying attention. We have a few questions here about the Conowingo Dam. All right, this would be Tony and this would be Doug probably together taking the leads on these answers. They essentially in reference to all the sediment and the legacy P that exists currently behind the Conowingo Dam. What do we do with it? How do we get it out? And where do we put it?
I'm going to open by saying I'm not a reservoir engineer, and I don't know if I have a good answer on what should be done. I think the consensus is that it shouldn't be dredged at the moment. At least I think that's what the most recent report kind of recommended. It was not to dredge the Conowingo. I don't know if dredging it opens up a can of worms that you don't want to open up. So short of that, I'm not sure what the other options are, but maybe others on the panel want to comment or.
It sounds like a policy issue, and I support the policies of the president.
A good federal employee. All right. Okay, there's a couple questions. We dodged that one very well, didn't we? Okay. There's a couple questions relating to soil health. Okay, and if I can package these kind of together, hopefully get everyone's question in here. soil health is a big push of NRCS nationwide right now. There's a lot of energy going into soil health being a primary element of stewardship. Um, going back to the trade-offs that we've mentioned a couple times today, the trade-offs of incorporating P sources and not incorporating P sources, the trade-offs of having to break macropores versus not breaking macropores, the trade-offs between higher than desirable P levels and mycorrhiza and those kind of things. In the whole context of soil health, where does our soil phosphorus management come into play? You may start, sir.
In my new role, this is principally my area of responsibility in Kentucky because I know nothing about it, so that makes me an expert. So the only thing that concerns me is it depends on who's spinning the soil health story. Some of it, I think we should be cautious. If it seems too good to be true, it likely is. And so while we're dealing with a legacy soil phosphorus issue here, many parts of the world it's very different, and farmers are being told if you follow this soil health approach with cover crops, no-till, multi-species cover crops, that being a real key. Manure is by some people listed as a pillar of the soil health kind of temple. Then you don't need nutrients, Cover crops provide 50 pounds of phosphate per year per acre. I mean, that's only true some of the time. And where's it coming from? We're not weaving gold from straw. I mean, that phosphorus has to come from somewhere. You may be relocating some up. But the manure thing kind of concerns me. In the no-till, these people, there's places where this isn't an issue yet, but they're saying, well, put some manure out there, put some cover crops out there, and it's all good. The system isn't that simple. So, if it seems you're not going to get free fertilizer. You're going to have to do something to get that fertility in there. And by the same token, it's not going to disappear water quality concerns. It may exacerbate some of them. I mean, the science is still there of transport and source. And if the things you're doing to build soil health are increasing soluble phosphorus at the surface, it is likely you are going to increase phosphorus loading. And then that's a trade-off you have to assess. Is the increased macropores and organic matter worth increasing dissolved phosphorus in runoff? And maybe it is. I'm not saying whether it is or isn't. I'm just saying that's the reality.
Anybody want to expand, like Doug?
I would say soil health, it's kind of like just wanting a single silver bullet. I think it's going to be a part of our arsenal, but we need to be wise about how we travel down that road. Make sure that we don't load manures into the system and build soil test values above what the crop demands are. I think we'll need structural BMPs to take care of some of the transport issues. I think it will be one tool or one set of the tools to reduce phosphorus, but I would dare say that it's not the silver bullet that's going to solve any of our resource concerns, because if we count on it to take care of one resource concern, whether it's phosphorus or erosion or anything else, we're kind of squeezing that balloon and forcing something else out the other end.
All right. Go ahead, sir.
Oh, I'll just say that there's some really good agronomists and soil scientists who are behind soil health, and to them, it's not a reductionist approach. It's really kind of a holistic approach. And I've been critical of it because I actually do reduce everything down to what happens with the phosphorus. And so it's easy for us to pick on these systems. But I think the objectives behind it actually are to bring in all kinds of processes and services. And so over time, I think it's an important movement, but that it right now is comprised of hypotheses. It's not done yet. Just as you said, we're going to inch forward. And so I think particularly for action agencies, that it represents a really good way of packaging and forwarding their programs, but that you have to be cautious about advocating, any particular approach because, as we've shown earlier, they're trade-offs.
Okay, great. There's a few questions here, Walter, which have to do with the ecology of water bodies and systems. One of them is relative to the Lake Erie fisheries. The question really is, does productivity never increase in freshwater when it's going from mesotrophic to eutrophic conditions? Does productivity not increase? That's what it said. If you're going from, in a freshwater system, if you're moving from a mesotrophic state to a eutrophic state, what happens to productivity, primary productivity?
It would generally increase as well. Normally there's a reasonable relationship between nutrient loading and primary production in most aquatic systems. So, as you go from mesotrophic to eutrophic, primary production would very likely increase. Some people, the lakes people, of which I'm not an active member, have done some wonderful work on examining that question through what we call comparative ecology. That is, assembling data from hundreds of lakes. And what they found was that phosphorus indeed was very important. Secondly, the dimensions of the lake were very important. Shallow lakes can become eutrophic quicker than deep lakes. And thirdly, the water residence time of the lake played a really important part. With those things being considered, they found some really strong relationships between loading rate and trophic conditions. So oligotrophic, mesotrophic, eutrophic. They tended to increase, clearly increase.
All right, thank you very much. There's another question that's going to be in your wheelhouse, is about the dual approach to tackling the nutrient enrichment in the Chesapeake Bay, the balancing nitrogen and phosphorus and tackling both at the same time. And the bottom line is there a sweet spot, or are we going to have to run one of them down and then run one nutrient down and let the other nutrient catch up till things get better?
I think the basic notion has to be that we need to reduce the loading rate of both N and P. I think the global experience has been people have tried to reduce just P because it was technologically easier, or at least it was. And what they found was they got a positive response in the freshwater part of these ecosystems, and the more salty and marine parts went off a cliff. So that's some of the motivation, the actual real-world motivation for doing both nitrogen and phosphorus. A second point along these lines is that the relationship between nitrogen and phosphorus loading apparently is also important. So if we have huge differences in the amount of nitrogen or phosphorus coming into these systems, we can generate some odd algal assemblages that might not be good for the food web. This is kind of a new area of research, but there are a few people pushing real hard on that. So what their message at this point is, try to keep that N to P. I'll back up. Reduce the N to P loads for these eutrophic systems, and try to keep the N to P loads in a ratio that healthy algae like.
All right, thanks. And one last very specific question relating to the resurgence and growing oyster aquaculture industry up and down the bay. What impact is that going to have?
I think there are two or three answers to this. The global answer, will that fix the bay water quality problem? I believe the answer to that is no. The second point, by establishing some of these oyster sanctuaries, the idea is that they may spread oysters around the bay. That's all to the good, but I don't think we will, in my lifetime, which, given my age, is probably not all that much longer, oysters are not going to fix our water quality problem. They will do good things, but they're not going to fix it because recent stock assessments have said that the current oyster stock in the bay is about 0.3% of what it was in 1900. So, I mean, they are really almost rare organisms in the bay compared to what they were when they had a really strong effect on water quality. The idea that oysters will fix us in the short run does not make sense. I'm delighted with the response of Waterman and converting to aquaculture and getting into niche markets and making a decent living. I think that's pretty cool. We also need to remember that oysters are not the only critters in the bay that filter and clean the water. There are an abundant variety of worms and clams that also do that. If we can get oxygen into the bottom water so that they can complete their life cycles and live year in and year out, they will absolutely be a big help, probably a far bigger help than what oysters will be in the short run. Short run being the next decade or two.
All right, thank you very much. Okay, we're going to shift gears over to some modeling type questions. Pete, you might want to get that microphone down towards your end of the table. Okay, when I'm bundling a couple together here, but when models are developed and go live and they're being used, they're based on a set of parameters and assumptions and assessments built into them. Why is it so hard to change some of those parameters after a model is created? The example they give here is there's one model that uses the number of animals, poultry animals, to feed some of the nutrient fluxes. And why is it so hard to incorporate new numbers like that into a model after it's already been created and calibrated and out there working?
Well, it's never hard to change a model. I mean, you just get into the code and change a number. So why something doesn't change very fast is a different question. The person running the model has to know how to make the change or why to make the change or have a good reason to make the change. Sometimes you have a sort of a institutional legacy with these models. You know, they're developed in the 80s. They get passed to the next person and the next person, and that each time they're passed, that person may forget something or not know how something works, or have to relearn it, and that takes time. So you got to have somebody who knows how to make the change, and have a good reason to make the change, because you have to understand that when you do make the change in the model, you know, it's going to change the output, it's going to change other things in there. So you got to know what all that sort of domino effect is going to be down the chain. But it's not hard to make a change in a model. It's actually very easy.
Just change the number, right?
That's right.
Okay. All right, Andrew. There's a question here about the what's happened down in the Illinois River watershed, and about the court-imposed limits, which caused a lot of chicken litter to have to be moved out of the watershed. And the Arkansas farmers had to comply with those court orders. And the question is, who took the economic burden for that? Who paid for that to be moved? Did it cost the farmers, or was there some other process in place to help limit that cost?
I guess the answer is.
Look closer.
Sorry. I guess the answer is probably about a third to a quarter of the cost was subsidized by the companies in terms of the export program. So a certain extent of that it was subsidized. The state did employ in both sides of the line nutrient management planners that would go out to those specific watersheds, and so they got probably plans and interaction with a planner on a higher level than might be normal. So that was the state funding that. So hope that answers.
Yeah, I think it did. And while you had the microphone, a totally different question, but I know you mentioned it, and I think someone else mentioned it too. We have someone in the audience asking for some more information about the Discovery Farms Network and how that works and how that gets the word out.
I'll go back to that first question, though. I just remembered the other 70% was burdened on the farmers. The companies did not, other than the subsidies, the lawsuit, prior to the lawsuit, the farmers won the case that the manure was theirs. And so it is their responsibility, and that's in the fine, print note. So to a large extent, the farmers are having to pay the price for that. And I've talked to a few people here, and I know there was a lot of concern and a lot of angst in those lawsuits and those cases that came out within the farming community as to why the heck weren't we involved. The first day you knew about it was reading it in the paper. They were not in, this is in the Arkansas, Oklahoma. They were not involved in the process. The Poultry Federation, to a certain extent, was an entity that was a spokesperson for that farming group that, did speak for them. But the farmers themselves felt that they weren't a part of the process that dramatically affected. The bottom line is that the farmers and the poultry are still there. They're thriving, and the beef farmers who depend on it, are still there too. It's adapted and it's changed a little bit. It is not what it was before. But again, paying the price. The other thing you have to remember there, and this was before I went there, there was probably sagebrush, and the pastures the water quality has to be a little bit better because they are growing pastures and grass and on slopes that they could not get it to grow on before they were using poultry litter. So there is that benefit, and we tend to forget what it was like prior to that. So land coverage has increased dramatically, and it's like others have said, it's a bit of too much of a good thing. So I'll stop there on that.
Okay.
But the Discovery Farm program we took it from Wisconsin, and it's a program, has to be Fred Madison and Dennis Frame were the ones that thought of it up there. We've adopted it. We took a group of farmers up there. We actually went to review the program, and we thought it was a good idea. We took a group from Farm Bureau. They liked it so much they came back and talked to our legislators. We got some, basically the Discovery Farm program is an effort to document on farms the benefit of conservation practices. So that if you have a cover crop, that's one of the ones we're looking at, if you have that in place, you've got some documentation prior to, during, and years after what the reduction in nutrient runoff might be. One of the premises that one would go into that is that you don't have a problem, that you would do some monitoring prior to see if what the perception was that you might have had a problem, whether that was right or not. And one of the things, the keys to it was, it's led by myself and, like I said, Fred, he's retired now, Dennis, and other people as researchers. But we never went into a farm and said, this is what you need to do. We don't make a living, and I wouldn't want to, out of farming. And we weren't going to go in there and say, this is what you should be doing. We wanted the farmers to say, in each case, what was the concern that they had that they wanted to know more about? And one was cover crops, how much benefit. The other one with the poultry was, how much nutrients am I losing from my production area? We've moved on from land applications, production area, because production area, you can see the litter when it's moved out. You can see the dust from the fans. EPA see that as a point. They're trying to see that as a source. And so that got farmers very concerned, because if you can see it to certain people, then it's a problem. Is it really a problem? Nobody knows, but the perception was that it was. And so they wanted us to have some documentation. So part of the key was to get documentation on actual BMPs on the land over a period of time, so how effective they were. And the second key part of that program was our extension people in Arkansas would recognize that farmers would listen to other farmers more than they would us standing up talking about something. And so there was a peer pressure. Other farmers would follow something else that they had done that worked. If it worked, it may not actually be exactly the same practice or cover crop, but they would tweak it and they would adapt it to their farm. And that seemed to us, we were using the farmers as part of our extension and mouthpiece. And Just again, it's getting the farmers to be empowered and make part of that decision. We went to legislatures to try and get funding from it. We took one of our farmers to speak. So, I got up and I rattled on a bit like I'm doing now, but the farmer got up afterwards. One of the legislators came up to us and said, it was nice for you to hear you talk, but I'm glad you brought a real person, the farmer. And so that's where, we've realized that that's where a lot of our message really gets the rubber hits the road.
All right. Thank you. This gets kind of the line of BMPs and soil phosphorus dynamics. The questions meshed together have to do with the use or need of starter P on high P soils. And is there any research going on with the specific technical delivery of phosphorus right to where it's needed, right to the root of a young plant, instead of making the young plant suffer before it gets root system out there to capture the P?
We talked about soil fertility testing, critical levels needing some work, but in general, you may not want to hear this, but we think they need some work because the critical level may be somewhat lower than what we think it is in some situations. In other words, we say you don't need phosphorus if your soil test is above somewhere in the range of 50 to 100. And maybe that number's lower or higher. We need some more precision in that number. But generally the science is good. Again, the reason for this symposium was to say what do we know that we can all agree on? And if your soil test is up in that high level, there's plenty of quantity there. If you're seeing deficiency, it's probably an intensity issue, sidewall compaction, cold, wet soils or dry soils, limiting diffusion. Or in this area, what we see is spatial variability in soil pH, inducing a phosphorus deficiency that is visible. These are intensity issues. Adding more phosphorus is one solution. Another solution is to make sure your soil is properly limed. Alleviate sidewall compaction. Use a small amount of starter in some situations is beneficial, but typically it's not really what's needed. And ultimately, it is extremely rare to see early season phosphorus deficiency caused by one of these issues result in yield loss at the end of the day, because as soon as that plant starts to develop and those roots get out there, they can get enough phosphorus to the plant to support the yield. It's rare for that very early phosphorus deficiency. As long as there's enough quantity there and the soils warm up, it'll overcome it. And, we talk to a lot of farmers and they don't like to see purple corn. But this is one of the advantages of a farmer-based approach like Discovery Farms, which, I followed and I think is a great approach. Strip trials are the best way to answer this question for yourself. And Doug last night brought up a really important point. The early days, and I know everyone in Maryland believes they invented no-till. In Kentucky, they believe they invented no-till. I was actually shocked to find that out when I got there. No, they invented it in Maryland, but Indiana, though, Doug contends, and the early adopters of no-till, I've heard farmers in Maryland say, hey, look, we first started trash farming. It looked bad and we didn't like it. It's the same thing with looking at some early purple corn. But in the end, I think it has to come down to a business decision about yield, and you're not going to need that starter P in a high P soil. It's pretty well understood. There's not a whole lot of debate.
Okay, the second part of that was, I'll remind you what the second part is first. The second part is there any work going on about precision delivery of phosphorus right to a young plant root in a system where it might need it?
Well, I guess what I was going to talk about related to that. I've been interested in this issue and placement of phosphorus. So I've been just trying to do just a little bit of work to try to figure out procedures to study this very issue. And my premise has been we see phosphorus deficiency when it cool and wet or the sidewalk compaction. So we did a little bit of work in a growth chamber, and we could induce phosphorus efficiency in plants. And then a couple of weeks ago, we had some pots. We're going to try to redo the experiment, but place phosphorus 2 inches below the seed to see if we could put them back in the growth chamber, induce phosphorus deficiency in the plants after it got cold, and prevent that with a little bit of fertilizer below the roots. And on Tuesday, we went out to look at the plants before I left, and I would appreciate it if somebody would explain this to me. Of the 10 plants with no fertilizer, I had one plant that was purple. Of the ones that we put fertilizer, there's that, about 2 inches below the root. I had, I think, 7 other plants exhibit phosphorus deficiency. So,
Sounds like the research needs to continue.
yes.
I have an answer. Witchcraft. Greg Binford did a lot of work on starters and pop-ups and fertilizer placement on the Delmarva. And generally, his conclusion, and he had as much data on it as anybody in the world, I think, was, soil test P was the end-all be-all. Starter fertilizer was fine. Some of the pop-ups are putting it below the row. You've got to be cautious. Every once in a while, there'd be a deleterious effect. So there was some caution there. I kind of wish he was here to expand on his data. He's actually out in Iowa talking to them about the Chesapeake Bay today. Placement is definitely important from the starter perspective if you need it, but ultimately soil test is going to give you a good indication, as far as what you actually need. There's work going on development of fertilizer delivery, not as much on placement, but technology on the phosphorus fertilizer. So far, there's not a lot out there that's very promising that I'm aware of.
All right, thank you.
I went to a conference, a fertilizer conference, a couple of months ago, and I was just amazed by the companies that were the fertilizer. Some of the smart fertilizers they have now are just amazing. They're not obviously on the market yet, and some of them are going to be very expensive at the moment, but that price will come down. But they're coated nanoparticles, it's amazing technology that we would think a few years ago, no way you could do that. They're now looking at being able to have those fertilizers dissolve or release when the plant needs it, and in some ways being able to respond to the plant, not just to weather, but to actually the plant needs. So there's some technology out there, and as I say, a lot of it is done by the fertilizer company.
Okay, let me just go to low-tech this is manure, but at the University of Maryland Eastern Shore, we ran the Subsurfer. This is poultry litter applicator, and it's one of the places where we saw kind of the win-win story that we were looking for. We saw yield bumps associated, and I showed you some of the data, with subsurface placement of the poultry litter, and where they were the largest was in years in which there were droughty conditions. So it's a hypothesis, but we've actually got a number of grad students up at Penn State, UMES, looking at this, that poultry litter is actually serving as a kind of a zone of soil moisture conservation, and so is helping out in these drier periods of time. So that little band of poultry litter down there.
Okay, we're going to switch gears to hydrology. Tony, a couple questions. One has to do with temporary field leads or field drains, which are shallow, very excavations in the soil surface that take ponded water off of a field. The question has to do with what potential contribution do those practices, which come and go annually when they're put in and they are destroyed later on and put back in the next year, not permanent, drainage ditches, but these very shallow temporary field drains, but moving phosphorus off the landscape into a receiving body.
Well, I'll be honest, I'm not familiar with that practice, but I would have to hypothesize that if these are shallow drains and they're intercepting the zone of high P soil to the extent when the water table comes up and intersects those, that you're going to move phosphorus, or if there's preferential flow pathways that are active that intercept those shallow drains, that they, if they're moving water, they have the capacity to move P.
Okay. Do we want to add to there? We good? All right. And kind of while you still have the microphone in your hand, sir, you showed some data about the critical zones surrounding drainage ditches and how if you increase drainage intensity, you multiply that area that would be considered a critical loss zone. If you change the management within that critical source area adjacent to a ditch, example, nutrient setbacks or buffers, or et cetera, could you have a major impact on what's the phosphorus just leaving through that ditch system?
I think over time the answer to that would be yes. If you change the management, or if you're phytomining, or removing P from those zones, or somehow preventing it from getting into the ditch, then I think yes, you can probably make a difference in those contributing areas, those areas that are within 5 to 10 meters of the ditch that are contributing most of the P.
Okay.
If anybody else wants to comment.
Good? Okay. All right. I'll throw this one out to anyone who chooses to jump on it. What's the role in carbon in phosphodynamics, and should we be worried about carbon in our soils and carbon in the loading of phosphorus into waters? I think the question is relating to carbon in soils, whether you have organic matter or carbon content of soils, and the relation between the carbon content, organic matter content, and P dynamics.
A stab at the closest. That it would only benefit. That if you're looking at carbon increase or organic matter increase, that means the soil has got better structure, its water holding capacity is better. So I could only see a benefit if you're sequestering carbon. It means the health of that soil would improve, and the chemistry such that pH and other things that would increase fertility, which would increase plant uptake, availability. Therefore, I could only see that having a benefit on the general soil fertility.
Okay. We're getting to those questions that I kept shoving over to the bottom right corner because I don't quite know where they're going to go, but we're going to tackle a couple of them here. A couple of them deal with, we've mentioned today, different speakers have mentioned differences in different parts of the country, differences across state lines between everything from fertility recommendations to risk assessment tools to state strategies for reducing nutrient enrichments. Why is there so much difference, I think, is the bottom line question, across dotted lines on the map?
That's clearly a policy issue.
Well, answer it.
To get to the 4 R's, bring it back to the 4 R's. It's an objective, driven system, and objectives are different in different states. Clearly, everyone has a boss, and we do what we're paid to do. Even politicians, and so politicians have different bosses in different states. So some of that's policy. I think generally you see here, some of the people that have worked with us over the past year as we organized this symposium, and the conversations between all of us, often off-color conversations, we all kind of get along in one sense or another, have mutual respect, admiration, and in some cases love for each other. If I can be so bold as to show my emotions. And few of us even lived together for a while. And I won't name names. And so the science is the same across state lines. Transport mechanisms differ in different regions with different pathways. talking about the P index, we've always kind of argued that we shouldn't have state P indexes, that perhaps we should have P indexes that are specific to physiographic provinces. Have a Piedmont P index, a coastal plain P index, a mountain P index, or what have you. Climate does shift north to south, east to west, but generally those differences are a function of differences in policy objectives.
Okay, I want to tackle this one because it's, I think this is one that gets at a lot of issues. But as a scientist or somebody working on these problems, you could be a regulator. If you look historically at a lot of the decisions, we've parceled things out. So there's states' rights, federal rights. That's kind of the issue. But there's ego and hubris that's involved in all of this, and I think that it's a part of the soil testing story. So I listed a few, and I didn't know any of these guys, but there's Mellick, there's Bray, there's Olson, there's Morgans. And what you saw was, under the auspices of local variability and given their resources, somebody basically solving a problem in one place, and then somebody down the road solving the problem in another place. And over time, those differences, which can be explained, maybe it's ego, maybe it's just, the fact that the telephones didn't work very well then, but they've become cemented, and we've inherited those. So this is that kind of inertia that you get that we're trying to overcome right now. And so Josh has actually been very funny about this phosphorus community that we have. It's a global one, so we know it's not a large community, but the people that are working on non-point source phosphorus issues, who are in their countries, they're the leaders of that. It's no more than about 20 or 30 people, and they work very, very closely together. If you look at our region at the nutrient management work that's gone on around phosphorus, you have folks like Frank and Andrew who cross state boundaries, all the other guys who were here as well, and who tackled the phosphorus issue as basically a Chesapeake region. It was really admirable. So if you start to compare the response in this region, where there are problems, and the problems I think are largely tied to kind of geopolitics and things, crossing state boundaries, you see some of the best coordination that you have in the country. And it has to do with kind of putting ego aside and going after the issue itself. This perpetuates itself. You see so much of the reward coming if you have your name tied to something. We go into these very arcane fields, and it's really nice to get some kind of recognition for having done something after you've invested 20, 30 years of your life into something. And so I think there's all these motivations to kind of go back to your bunkers and work by yourself, but that these problems are so big, what is happening right now is a real kind of a watershed moment where you have the collaboration. You have people fessing up to what they don't know. That's really hard to pull out of people. You have people fessing up to the fact that the narrative that we've used for so long, because it's a simple one, I could talk to a farmer without making him think that I'm Satan and I'm coming out and telling him that he's a bad guy. Those are disappearing. The people are being much more open about it. And those all contribute then to trying to tackle these very big, these wicked issues that require, I think, a lot less ego than they've had in the past.
That being said, and ego is being laid out on the table, researchers spend a lot of time working on BMPs to tackle difficult problems. And researchers become convinced that some of these BMPs work. Okay? Yet sometimes when the BMPs are imposed on landscapes, the water quality doesn't change. Why?
It's complex. And I don't say that to be funny. It is complex. So before everyone leaves, I've had kind of a thought jogging around in my mind of kind of one of the take-homes I had today. And I felt, I don't know, really useless for a while. We kept saying, cover crops are good, cover crops are bad, injection's good, injection's bad, tillage is good, tillage is bad. And so if I'm a farmer, that's the way I kind of tend to look at these things. What do I do? Who do I listen to? Do I throw my hands up in the air? And I think, this gets to what's coming next as well. These BMPs do work in the right place, the right time, blah, 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 blah. But how do we make that decision? What's the right time? What's the right place? What's the right source? And I think the future, you may not want to hear it, but we use these all the time. Soil test, that critical level, taking a soil test and predicting crop response is a model. There's a data input. There was a crop response curve that was made on someone else's field, on other fields over time. You go out and soil sample, you input that number into that model, and it predicts the likelihood of response if you fertilize. That was a model that was developed in the 30s, 40s, 50s of soil tests. The future, I think, is the things that Pete's working on. These models, these indexes, the P index and so forth, as they become more sophisticated, give us that ability. They capture that BMP's effectiveness, and I don't know that they're there yet, but I have hope for a future where the models are more sophisticated and capture the spatial variability and temporal variability of the benefits of these BMPs, so that it's almost like that game Sims, farming Sims or whatever, where you're simulating your farm or whatever. I see it on Facebook. People always ask me to play it, and I'm like, I don't want to play that game. But you know what I'm talking about. And so if we had it in a format, and part of this is delivery. Pete develops a model. We need someone that develops apps that are cool. Put it on the app store, and you sit there in your house with your game that is user-friendly, and you say, this is my plant date, this is my hybrid, this is my population, this is how I want to fertilize, and it predicts this is going to be your runoff P, and then you say, throw a cover crop in, and it comes down if it's in the right place. If it's in the wrong place, it goes up. If you're on the Eastern Shore and you throw in tillage, it comes down. If you're in Frederick and you throw in tillage, it goes up. And you can sit there very simply as a farmer, enter specific practices and specific dates, and it captures that temporal and spatial variability. I think we're getting close technologically to being able to deliver that. So if there's something I'm hopeful for in the next 10 years, it's that kind of model.
In Wisconsin, they just completed a multi-year study on the paired watershed, and they use their P-index, which is a quantitative model, to identify where in the watershed and what practices would be most effective at reducing P loss. Just this past year, they measured a 37% reduction in the phosphorus loss in the local stream. So I think, and I heard, as people were discussing this project, they were talking about things in Vermont and I think Minnesota where they didn't see these impacts. So I think one of the differences, and Josh is talking about, is Wisconsin's got a very good tool. They use it really well. So one of the differences is that they use their tool to find the places they thought would be the most effective as far as transport, and putting the most effective practices in those places. So if you're just putting something on the landscape and it's not a place that's going to generate a lot of runoff, you're not going to see that impact. So maybe this combination of these tools and this monitoring, we can see a better impact of what we're trying to do.
I was just going to say that Andrew and I collaborate primarily now by writing papers about case studies. And so we look around the world, we call up our friends and write a paper about what works and what doesn't work. And it's a lot better to talk about what doesn't work, because I think that's informative for people who are overselling things, but maybe we've oversold the doom and gloom today. And there are a lot of case studies. Most of them have to do with smaller land areas or areas where there's less intensive production, but there's a lot of case studies that are successful case studies. And I did my PhD in the New York City watershed, which is pretty unique because New York City was throwing a lot of gobs and gobs of cash at it. But just small northeastern dairy farms in which through a certain package of BMPs, they're able to reverse the phosphorus problem there. And so it's really nice to be part of that type of a solution. It costs them money and they probably spend it, not as efficiently as they could. But you can pick studies that, if you hone in on scale, are successful. They can be at the level of a farm. They can be a level of a small community. So it's not that they don't exist. But when we start dealing with these larger water bodies in the Chesapeake Bay, I think Walter gave the introduction today. I mean, you think of water bodies in the world that have a larger kind of catchment to volume of water, and you're hard pressed to come to anything that's even orders of magnitude there. And so this is a really, really tough nut to crack at this scale. And the folks at EPA with whom we work, they recognize that. They're trying to push for people to try to connect more to a local benefit. It's hard to do if you live right on the banks of the bay. But upstream, certainly that's the way you're going to move people. And we have examples. So we've got examples in Pennsylvania. They're conservation-based ones. They're now kind of out of date because they're not the current problem in the context of the TMDL. But they're very, positive things. These are the BMPs that we all push. It's not just kicking things down the road. We actually take them for granted to some extent. So I think that maybe we should have spent a little more today talking about the success stories, but that's not, that's, our concern is overselling that. And, so maybe that was our fault.
Yeah, I just quickly, I would hate to think, that question was such that they thought that we had said that BMPs are not working. I don't think that's going to be, I would like to say, no, that's not true. As we know, the right BMP in the right place will work. And I think perhaps Pete touched on this idea that where we're measuring it at the bay, if we look at the edge of field, and NRCS are doing that now, they're requiring some monitoring edge of field when they have their cost share programs to put BMPs in. If you look at it at the edge of the field, you will see a benefit, I believe, in most cases. So I would hate to think that we have given somebody, just one person, the idea that these BMPs don't work. We think that the idea is that they may not be a silver bullet, but they will reduce runoff. And having a BMP in place is certainly better than not having a BMP.
All right. Tony, you want to add to that?
Yeah, I just wanted to add that I think a lot of these BMPs are also very complementary. Sometimes if you put, let's say, a riparian buffer or forested buffer, and you haven't done anything else up in the fields, in terms of management, that you can't expect it to solve all your problems. But if you've got other BMPs in place that are addressing problems on the farm, on the field, runoff or erosion or what have you, then these BMPs are very complementary and can, serve to, produce additive effects, or additive benefits. So, I think, there are, and as has been echoed here, at the field scale and this in small basin scale, you can see benefits from having these things in place.
All right, thank you. I have 2 cards left. This one bothers me. I'll read the question as it's written. This question is for the young scientists.
Bring it on.
We'll leave it at that. This question is for the young scientist. What are the current knowledge gaps and research needs to move us further down the road?
Well, I think one of the important ones is going to be getting back to that last question, making that link between what we do in the field and what the impact is with water quality downstreaming, being clearly establishing that and understanding these processes of scale. How long does it take? At what scale are we going to see things? And being, historically, our research has probably been at plot and field scale. Now we're starting to get beyond that and understanding those processes. So that's one of the things that we're going to be working on.
I'll definitely echo what Pete said. As a field scientist, I'm often focused at, the plot and the field scale, but, connecting these scales is, kind of an ongoing challenge and trying to figure out, how plot, field, small watershed, and how these scales are linked, what's going on in stream processes, and then delivering that information, in a usable way for folks like Pete or others who are trying to model and improve the process representation in these models, because ultimately what I see at a field scale or in a stream is only one little spot on the landscape, and in order to translate that into useful management information that can guide watershed scale management or provide information about how long it's going to take, to clean up, say phosphorus or nitrogen or what have you, then, the results of the work that folks like me are pursuing and Pete and others, largely are to help improve models. And so there's a lot of work right now going on to try to understand this subsurface phosphorus transport pathway that we're all concerned about on the Delmarva. And so we have a lot of point scale measures, we have mass balance measures. They've all given us some insight, but we still don't have, the necessary information to represent those processes better. And so, I think the science is pushing forward with better technologies, more precise measures, big data, those kinds of things can provide a lot of insight, finer temporal scales. So that's, I think there's quite a bit, we still can do.
And we're not proceeding in the order of youngest to oldest here. I just want to make note of that. But I guess from my perspective, as an extension person, I kind of view my role as transferring what these guys do to the end user and and education is a big component of that. I think what both Tony and Pete just brought up is very important in that context, from the idea of if we can connect these processes to what's actually happening and model what's going to happen in a system response, that will help us to set realistic expectations. And how that helps in the educational component is perhaps it'll take some of this pressure, I think Pete said it earlier today, Kleiman, of this hyperbole and rhetoric and finger pointing and say, here are the realistic expectations, achievable expectations, perhaps, and take some of that pressure off, which makes education easier, because I found that education goes out the door when people are just entrenching in their own position, and that's true in any field. And then from a more realistic, what is my kind of wheelhouse of education stuff, what I said before is taking these tools, and we have to figure out how to package it. PowerPoint slideshows and county meetings with chicken and dumplings are not the future of education. I think Discovery Farms, for a long time, I've been a huge advocate of a farmer-based approach. If the farmers aren't saying we're coming out here to help develop the answers and the solutions, that's the best way to educate and transfer, because they become part of that investigation team. And then I am also a big believer that technology is always going to help alleviate some of these problems. At some point, I said this last night, Malthus thought we were all going to die because we couldn't produce enough food. And Carl Sprenger came along and figured out, the law of the minimum and soil fertility, and we're all still here today. Technology is always going to come up with answers, and I think from an education standpoint, we need to incorporate some of these things, simple software-based tools that help that farmer make that decision. And Apple's simple, and you guys can download it from Pete's website and run it, but I'd like to see it in an app with cartoons and funny stuff that makes it easier to digest, that you can run at home.
I think one of the things that I've been most excited to work with in the last few years is conservation at a landscape scale. So we spent a lot of time today talking about soil test phosphorus and manure applications, and that's very important at the field scale. But I think one of the projects I've been involved with, we took farmers at we call it a 12-digit HUC scale, which is roughly 10,000 acres. We got all the farmers, or the big farmers, in the room that controlled the majority of the land. And we talked about, okay, what can be done at the landscape scale? This is where we see potential for these conservation practices. This is where this set of conservation practices may go. Those are field scale. This is what we can do at the edge of field. As we move down into the stream network, what can we do here? How can we engineer the drainage ditch network to better handle nutrient loading and removal, and that's really been some exciting stuff for me. And I'm kind of hoping that we can work with more groups of farmers in a similar manner, and really see the benefits of somebody mentioned these cascading conservation practices. And I want to figure out why I'm getting purple fertilized corn.
Any other young bucks want to add to that? Any other?
Okay, I don't feel young. I'm an administrator, so I'm not young. But I'm going to just totally take advantage of my young moment, because there was a point that I wanted to make. I wrote a bunch of things down because I thought the questions are going to go more to these big systemic issues. And those are the wicked problems we've got to address. I think it's pretty clear that we have some motivation from the environmental standpoint and from other kind of stewardship perspectives to move these systems along. But really, you got to connect industries and the consumers, and it's going to move at that point. Otherwise, we're going to be tinkering around the edge. And so you need something, some kind of a summit that's hosted by, a group like Walmart or McDonald's that brings in the fertilizer industry, that brings in the livestock industry and the crop producers. And we largely stay out of it, I think, but let them generate their own vision with their scientists and advisors. I think at that point we'll start to see the major changes that we're hoping that we're going to see.
And I will leave the door open for sage wisdom from this end of the stage.
Well, just to follow up on Pete, there was a story, I think Tyson, one of the Tyson families must have gone down to, with one of the Waltons on a plane trip down to the Bahamas and went over the Gulf and realized that it was impacting maybe where they were staying. They came back and they put in place a initiative that put out some funds, and I think it was around $200 or $300 million, and it was to do research, but it was very applied research. But they just decided we're going to do this, and exactly right. When that group said they were going to do something, it got done, and people paid attention. And so I think those are some of the things that that's not going to go away. There are a lot of these corporations now, field to market, all of these that are getting involved in that food chain and the sustainability, and that involves water quality. I do think that we need to be invested in that to an extent to make sure that agriculture is properly represented. But I think there are a lot more people and players, Gates and those others now in this game than just NIFA and the CIG grants that we kind of fed off of.
This is going to sound pretty pedestrian, but from the point of view of the Bay, this is a phosphorus conference, and one of the things that it would be great to know a lot more about, it has to do with the phosphorus that is glued onto the sediment particles that, for example, come over the Susquehanna or the Conowingo Dam, or down the James River, or down the Choptank River. My position is, and I think many others, that would say we really don't know how active that phosphorus might be. And I've heard discussions that said, the stuff that deposits in fresh water is just going to get buried, no activity. Other people would argue that there is the potential for some serious water quality degradation associated with the phosphorus that's attached to those particles. So I think I know that some of the younger biogeochemists who are very good are going to be working on this problem. And I think that is the kind of progress that will help us in model and in being able to assess the relative importance of particular phosphorus inputs into the Bay. So that's my 2 cents.
All right, great. A couple of parting comments. Okay, no. Reminder, anyone who wants CEUs for this session, do it at the registration table on your way out. Since I'm standing at the podium and Lynn's making her way up, I want to thank the Grain Producers Utilization Board, Bay Foundation, and Maryland Extension for putting this thing together. I have enjoyed it. It's been a lot of fun, but then I have a warped sense of what's fun and what's not. But I think it's been a very good day, and congratulations to y'all for sticking through it. And I want to thank all our speakers for participating.
And I'm not going to hold anybody up. What I wanted to do, because I have thoroughly enjoyed the day, I've learned a great deal. I hope you all have. I really wanted to thank our speakers for coming. I think this has been a first-class presentation. I don't think anyone can question that. Thank you, thank you, thank you. I want to thank the Bay Foundation for working with us. and Extension, anyone that was involved in any way. And as Doug said to me about a week ago, what are we going to do next year? So fill those evaluations out. Tell us what you want to learn about. This has been a great experience. Thank you very much. Thank you. Lindsay around the corner has done a great job helping to put this together. So thank you very much for coming. Have a safe journey home.